Take a breath. Do it slowly. Feel your chest rise, feel the air move down into your lungs, feel something in your blood pick it up and carry it to every cell in your body. Now here is what nobody told you about that breath. The gas you just pulled into your body is a poison. Not metaphorically, not in large doses. Actually, chemically, a poison, one so violent that when it first appeared in quantity on this planet, it didn't nourish life. It ended most of it. Somewhere around 2.5 billion years ago, something exhaled into the air of early Earth that had never existed there in any real quantity before. It was invisible, it had no smell, it didn't explode, it didn't burn anything on contact, it didn't look like a weapon at all. And it killed more living things than perhaps any single event in the whole 4.5 billion year history of this planet. That gas was oxygen. The same oxygen you just breathed in. The same oxygen your cells are, at this exact moment, using to keep you alive. For most of the life that existed on Earth before it showed up, oxygen wasn't a gift. It was a catastrophe. A slow, planet-wide poisoning event written permanently into rock that we can still go out and touch today. And here's the part that took me a long time to sit with. We didn't defeat that poison, we never got rid of it. We made a deal with it instead. A deal so strange, so costly, that we are, this very second, quietly paying the price for it inside our own cells, every single one of us, right now. I want to tell you how that deal was struck, because by the end, breathing is never going to feel quite the same. The book that sent me down this particular rabbit hole is called Oxygen, the Molecule That Made the World, written by a biochemist named Nick Lane. Lane spends his career studying something most of us never think about twice: the machinery inside our own cells that turns air and food into the energy that keeps us upright, thinking, alive. And somewhere in the middle of that work, he ran straight into one of the strangest, darkest stories in the history of life on Earth. A story about how the very thing keeping you alive right now was once the closest this planet ever came to sterilizing itself. I should say up front, I'm not going to agree with everything in that book. Lane pushes some of his ideas about aging and oxygen further than the evidence on its own can fully support. Some of it is genuinely contested inside biology, and I'll tell you exactly where the solid ground ends and the argument begins. But the core of the story, the poisoning, the deal, the price still being paid in your bloodstream, that part is about as real as science gets. And I don't think I've been able to look at a single breath the same way since I first read it. So let's go back. Back before there was anything on this planet that would recognize air as air at all. For roughly the first 2 billion years of Earth's history, there was essentially no free oxygen in the atmosphere. None worth mentioning. The air was a soup of other things, mostly nitrogen, carbon dioxide, methane, trace gases with no name a modern person would recognize. And the life that existed in that world, and there was life, simple, single-celled, ancient, had built its entire chemistry around an oxygen-free planet. These organisms breathed, in the loosest sense, sulfur compounds, iron, the raw chemical scraps of early Earth. For them, the absence of oxygen wasn't a limitation. It was simply the only world there had ever been. Then, somewhere in that world, a group of microbes discovered something extraordinary. A trick for pulling energy directly out of sunlight, not by eating other things, not by scavenging chemicals out of rock, but by splitting water itself apart, using the sun as the engine. It is one of the great inventions in the history of life. We call it photosynthesis. And it comes with a byproduct, a waste gas, essentially, exhaled the way you exhale carbon dioxide right now. That waste gas was oxygen. Here's the part that should genuinely unsettle you. This trick, this water-splitting, oxygen-exhaling form of photosynthesis, appears to have been invented a long time before oxygen ever actually showed up in the atmosphere in any real quantity. There's a lag, a real gap between the moment life learned how to make this gas and the moment the gas actually started piling up in the air of the whole planet. For a long stretch of time, something was producing oxygen, and something else was just as efficiently eating it, erasing it, keeping the atmosphere as oxygen-free as it had always been. The planet was holding its breath. Why would that be? Why would a waste gas get produced for so long without ever actually accumulating? This is where one of the more elegant answers I've come across enters the story. And it isn't really about the oxygen makers at all. It's about something the oxygen had to compete with. In the ocean of that ancient Earth, there were microbes called methanogens, organisms that produce methane, and that, in the process, quietly consume and neutralize a lot of what would otherwise become free oxygen. And methanogens need something specific to do their chemistry. They need nickel, a trace metal dissolved in seawater, almost invisible in quantity but essential, the way a single missing bolt can stall an entire engine. A team led by a researcher named Konhauser proposed in 2009 that the ocean's nickel supply itself changed over time. The early Earth's molten interior was releasing more nickel into the seas than it would later on, and as that supply slowly ran down, the methanogens that depended on it began to starve. Less nickel, fewer methanogens, less methane-driven mopping up of the planet's oxygen. It's sometimes called the nickel famine, and it's one of the more beautiful little mechanisms in this whole story because it means the fate of the entire atmosphere may have hinged, in part, on the amount of one obscure metal dissolved in ancient seawater, a rounding error in ocean chemistry, and the whole planet's future tips. Slowly, the balance shifted. The oxygen eaters were losing their grip, and the oxygen makers just kept exhaling the way they always had. And then, geologically speaking, almost overnight, the oxygen won. Here's how we know, and this is one of my favorite pieces of detective work in all of Earth science. You cannot go back in time and stick a sensor into 2 billion-year-old air. So how do you actually prove there was no oxygen and then pinpoint the moment that changed? The answer is written into sulfur, specifically into something called mass-independent sulfur fractionation, a subtle chemical signature that only forms a certain way in an atmosphere with essentially no oxygen and no ozone layer to filter ultraviolet light. When that particular signature is present in ancient rock, it's effectively a fingerprint reading no free oxygen here. When it vanishes from the rock record, something changed the atmosphere permanently. Researchers Farquhar and Wing, working through that signal in ancient rocks, found that this fingerprint disappears cleanly, abruptly, everywhere on Earth, somewhere in a window of about 2.45 to 2.32 billion years ago. Before that window, no oxygen. After it, oxygen, for good. It's one of the sharpest before and after lines you'll find anywhere in the geological record, a hard physical seam in the rock marking the day, geologically speaking, the sky changed. We call it the Great Oxidation event, and it's worth sitting with what that phrase is actually describing. Not a gradual drift, not a slow century-by-century creep, a genuine planetary transition compressed in geological terms into what is practically an instant, a fundamental rewrite of the chemistry of every ocean and every rock surface on Earth, all triggered by the metabolic waste product of some very small, very ordinary-looking microbes. Now, imagine you are alive in that ocean, in that moment. You are one of the anaerobic organisms that has spent nearly 2 billion years perfecting a chemistry built entirely around the absence of oxygen. And the very air and water around you starts filling up with a gas that, to your biochemistry, is not neutral. It is not harmless. It is actively, violently corrosive to the molecular machinery keeping you alive. Oxygen is a strange kind of dangerous. It doesn't attack the way a predator attacks. It attacks the way rust attacks iron, slowly, chemically, by stripping electrons off the molecules that make up your cell, tearing apart proteins, shredding the membranes that hold you together. Before the Great Oxidation event, none of the life on this planet had ever had to defend against that. There had been nothing to defend against. And now, everywhere at once, there was. This is the part of the story that rarely makes it into the tidy version of how oxygen filled the atmosphere. It's usually told as an origin story, the beginning of the air we breathe, a triumphant chapter on the road to us. It is much less often told as what it actually was for the life that existed at the time, an extinction event. Very possibly the single largest die-off this planet has ever experienced, long before the asteroid that ended the dinosaurs, long before any of the 5 mass extinctions you might have heard of, there was this one, Quieter, slower, written not into fossilized bones but into isotopes locked inside rock, and so much less famous than it deserves to be, given the scale of what it did. You'll sometimes see a number attached to it, a claim that this event wiped out 99% of everything alive on Earth at the time. I want to be honest with you about that number, because it's one of the places this story gets exaggerated in exactly the way I don't want to exaggerate it to you. That specific 99% figure doesn't come from the initial oxygen poisoning event itself. It traces back to a 2019 study led by a researcher named Hodgskiss, which found evidence for a collapse in the productivity of life in the ocean, a drop of more than 80%. But that collapse is dated to around 2 billion years ago, at the tail end of the whole oxygenation process, not the moment oxygen first appeared. And it's a measure of biological productivity, not a body count of species going extinct. Somewhere between the original research and the versions that circulate online, more than 80% collapse in productivity at the end of a long process quietly became 99% of species died, and that's simply not what the evidence says. The real story doesn't need the exaggeration. An atmosphere that used to be lethal to nearly everything alive, permanently rewritten by microbial waste gas, followed by a documented productivity collapse of more than 80%. That's already one of the strangest true stories on this planet. We don't need to round it up to make it frightening. Where did all that stripped away oxygen actually go in those first years after the seam in the rock record? Not into the air, not right away. It went into the ocean itself, into something that had been dissolved invisibly in every sea on Earth for 2 billion years. Iron. Picture the oceans of that time carrying huge quantities of iron in solution, invisible, colorless, the way salt water carries salt. The moment oxygen started reaching those waters in quantity, it did to that dissolved iron exactly what it does to a nail left out in the rain. It rusted it. Not metaphorically, literally the same chemical reaction, iron oxide, forming out of solution and sinking to the seafloor in thin, dense layers, one on top of another, year after year, for millions of years. Those layers are still there. You can go and stand on them today. They're called banded iron formations, striped bands of red and gray rock, some of them stacked hundreds of feet thick, found on nearly every continent on Earth. The red bands are rust. Actual, literal rust, laid down not in a puddle in someone's backyard, but across the floor of a planetary ocean, one of the largest mineral deposits on the surface of this world, and almost the entire reason human civilization has had cheap iron and steel to build with. The rails, the bridges, the girders in the buildings around you, mined out of rock that is, at its core, a fossilized record of a planet-sized chemical poisoning. Every skyscraper is standing on the scar tissue of the Great Oxidation event, every train track. When you touch a piece of iron today, there's a real chance you're touching something that formed as a direct byproduct of the ocean choking on oxygen 2 billion years ago. And the striping itself tells you something eerie about how that poisoning actually unfolded, not as one smooth wave, but in pulses. Band after band suggests the oceans absorbed oxygen faster than they could rust away the iron, then caught up, then fell behind again, over and over, a planet stuttering as it tried to swallow something it had never had to swallow before. Bands of rust, bands of ordinary sediment, bands of rust again. A heartbeat monitor for a dying atmosphere, pressed flat into stone, still legible today if you know how to read it. Once the iron in the oceans was finally used up, once there was nothing left to rust, the oxygen had nowhere left to hide. It had already poisoned the water. It had already poisoned the rock. Now it started rising for the first time in the planet's history into the air itself, in the open, unstoppable. For the anaerobic organisms still clinging on, this was the end game. Their choices were narrow and stark. Some simply died, in numbers we will never be able to count, leaving no fossil, no trace beyond their contribution to that isotope signature in the rock. Others retreated, down into mud, into the airless dark of deep sediment, into hot vents on the seafloor, into any pocket of the planet oxygen hadn't yet reached. And if you want to know where their descendants are today, you don't have to look far. They're still down there. anaerobic microbes living in oxygen-free mud, in the depths of your own gut, in swamp sediment, in the airless interior of your compost heap. Refugees from a war that ended 2 billion years ago, still holding the same shrinking territory their ancestors retreated to. But a third group did something different. And this is the part of the story I find almost impossible to fully believe, even now. Instead of hiding from the poison, some organisms learn to burn it. Here's what that actually means. Oxygen is dangerous specifically because it's so hungry for electrons. It rips them away from other molecules with tremendous chemical force, which is exactly what shreds cell membranes and destroys proteins in an unprotected cell. But that same hunger, that same electron-grabbing violence, is also exactly what you need if you want to build an extremely efficient engine. If you can control that reaction instead of merely suffering it, if you can channel that hunger through a very precise sequence of steps rather than letting it rip through your cell unsupervised, you can capture an enormous amount of usable energy out of it. You can turn the fire into a furnace with a chimney instead of a fire in a house with no walls. This is aerobic respiration. It's what's happening inside almost every cell in your body right now, in tiny structures called mitochondria. And it is, essentially, controlled burning. Sip by sip, molecule by molecule, your cells are doing a carefully contained version of exactly the reaction that annihilated most of the life on Earth 2 billion years ago. You are, at this very moment, running a domesticated version of a planetary extinction event inside your own chest on purpose for fuel. And the payoff for learning to do this is almost obscene compared to the alternative. An organism getting its energy the old way, the anaerobic way, through fermentation, the way life had always done it before oxygen showed up, squeezes out something on the order of 2 units of usable energy from a molecule of sugar. An organism that has learned to burn oxygen using that same molecule of sugar can pull out something like 30, not double, not triple, something close to 15 times more energy out of the exact same fuel, just by learning to harness the poison instead of hiding from it. 15 times. Sit with that ratio for a second. That is the difference between an organism that can only just barely scrape by, one slow chemical step at a time, and an organism that suddenly has the energy budget to do almost anything, to move fast, to grow large, to build complex structures, to think. Every animal on this planet, every plant, every fungus, every one of the roughly 37 trillion cells in your own body is running on that 15 times dividend. It's the energetic loan that made complex life possible at all. And the interest on that loan, as you're about to see, never stops accruing. That interest gets paid in a currency most of you have never seen named, but every one of you carries the debt in your own bloodstream. Controlled burning is never perfectly controlled. Even in the most efficient cell, in the tightest, most tightly engineered chain of chemical steps, mitochondria run to extract that 15 times energy bonus. Some of the oxygen slips the leash. It escapes the pathway before it's supposed to, and in escaping, it turns into something even more reactive than ordinary oxygen. Stripped down, unstable fragments of molecules, hungry for electrons in exactly the same violent way oxygen itself was hungry 2 billion years ago. Except now the damage is happening inside your own cells, on a much smaller scale, every second, for your entire life. This is the idea Nick Lane spends much of his career circling, and it's also the point in this story where I want to slow down and be honest with you about where solid ground ends. The idea that these stray reactive oxygen fragments are a major driver of aging, that the slow wear and tear on your proteins, your membranes, even your DNA over decades of life, is in large part the accumulated residue of tiny, uncontrolled oxygen fires happening inside your cells since before you were born. That idea is genuinely contested inside biology. It's not settled science. Some researchers think it explains a great deal of why we age. Others think it's a real contributor, but nowhere near the whole story, and a few think its role has been overstated by exactly the kind of dramatic framing I could easily lean into right now. I don't think anyone in that field would tell you it's fully solved, but here's what isn't contested. what every side of that argument agrees on. The reaction is real. It happens in your cells right now, continuously, as a direct, unavoidable byproduct of running the very furnace that keeps you alive. You cannot have the 15 times energy dividend without also generating some amount of this reactive residue. It isn't a design flaw you could engineer away with a better mitochondrion. It's baked into the chemistry itself. The same hunger for electrons that makes oxygen powerful enough to run your entire body is the exact same hunger that occasionally burns a hole in something nearby that wasn't supposed to be touched. You cannot get the furnace without a few sparks landing outside the fireplace. Think about what that actually means for you, specifically, sitting wherever you're sitting right now. Somewhere in the roughly 37 trillion cells that make up your body, mitochondria are running right now, converting the air you just breathed into usable energy, and a small fraction of that oxygen, this very second, is going rogue, slipping past the machinery, reacting with something nearby that it shouldn't. It has been happening inside you since you were an embryo smaller than a grain of rice, and it will keep happening for as long as you're alive, because the same trade that let complex life exist at all, the trade our microbial ancestors struck with a poison 2.5 billion years ago, is a trade that was never free. It bought life extraordinary power. It just never came with a way to fully contain the very thing that made that power possible in the first place. Because there's a reversal buried in everything I've just told you, and once you see it, you can't unsee it. You've probably spent your whole life thinking of oxygen as the thing that keeps you alive, full stop, the good gas, the one you die within minutes of losing. And that's true. But it was never simply the giver of life. It was, first, the destroyer of almost everything that had existed before it. Life didn't triumphantly discover a magic life-giving gas. Life was nearly wiped out by a toxic waste product, and the survivors, including eventually every ancestor you have ever had all the way back, only made it through by learning to weaponize the very thing that was killing everyone else. You are not powered by a gift. You are powered by a captured poison, and the capture was never total, and it never will be. There's a second half to that same reversal, playing out not inside your cells, but far above your head, and it's worth tracing all the way up, because the pattern doesn't stop at the scale of a single mitochondrion. That same oxygen, once it filled the sky, didn't just sit there as a breathable gas. High in the atmosphere, sunlight was hitting those oxygen molecules and doing something to them that had never happened at scale before. It was splitting some of them apart and reassembling the fragments into a different, related molecule. 3 oxygen atoms bound together instead of 2. Ozone. A thin, invisible layer forming for the first time in Earth's history tens of kilometers above the ground, built entirely out of the same gas that had just finished poisoning most of the life beneath it. And that layer did something extraordinary. Before it existed, the surface of this planet was bathed in a level of ultraviolet radiation from the sun that would have shredded the genetic material of anything trying to survive out in the open, on land, unprotected. For nearly the entire history of life up to that point, the only safe place to exist was underwater, shielded by meters of ocean pressing down overhead, filtering out the radiation that would otherwise tear apart any exposed cell. Land was sterile. Not because nothing could reach it, but because nothing could survive there for more than an instant once it did. The ozone layer changed that. It became a shield, absorbing the worst of that ultraviolet radiation before it ever reached the ground, and in doing so, it quietly built the precondition for something that hadn't been possible before in the entire history of this planet: life leaving the water. Every plant standing in a field, every insect crawling across bark, every animal walking on dry land, including you, exists underneath a shield built out of the exhaust fumes of the very organisms that oxygen had nearly annihilated a couple of billion years earlier. The poison didn't just get captured and turned into fuel down at the cellular scale. At the scale of the entire planet, it got turned into armor. That's the pattern. And once you see it once, you start seeing it everywhere in this story, at every scale you look. Something toxic, uncontained, spilling out as waste. Then, given enough time, Something learns to bend that toxin into a tool, a furnace instead of a fire, a shield instead of a threat. It happens inside a single mitochondrion, converting stray reactive fragments of oxygen into a controlled energy reaction that keeps one cell alive. It happens at the scale of an entire atmosphere, converting a gas that annihilated most of the life on Earth into a UV shield that let life walk out onto dry ground for the first time. Same molecule, same essential move. Catastrophe folded back into infrastructure. It's not a coincidence that repeats by accident. It's closer to a law of how life seems to behave whenever it's handed something dangerous it can't get rid of. Not eliminate it, never eliminate it. Just find a way to stand a little closer to the fire without being consumed by it, and then build your whole future leaning against that same fire's heat. Step back now, as far as you can, and look at the whole shape of what had to happen for you to be sitting here at all, breathing this particular breath at this particular moment. None of it was guaranteed. Not one link in this chain was inevitable. If the ocean's nickel supply hadn't thinned out when it did, methanogens might have kept scrubbing oxygen out of the system indefinitely, and the Great Oxidation event might never have happened at all, or might have happened on a completely different timeline, in a completely different way, favoring completely different survivors. If the iron dissolved in the ancient oceans had been a little more abundant or a little less, the rusting out process that finally let oxygen escape into the open air could have taken millions of years longer or shorter, shifting every downstream event that depended on it. You are not the product of some smooth, guaranteed unfolding of biological destiny. You are the product of a specific, contingent, almost accidental sequence of planetary chemistry that could very easily have gone differently, at almost every single step. And somewhere in the middle of that sequence, some lineage of your ancestors, not human yet, not even animal yet, just a small, struggling cluster of cells with no way of knowing what it was doing, made the decision, if you can even call it a decision, to stop hiding from the poison and start breathing it instead. Every single one of your ancestors, going back roughly 2 billion years, made that same choice, generation after generation, without exception, all the way down to you. One break in that unbroken chain, one ancestor who fled into the mud instead and never came back out, and there is no version of you sitting here at all. That's what's actually happening every time you take a breath. You're not just inhaling air. You're continuing an unbroken 2 billion-year-old transaction, one your ancestors entered into blind, that you were born already owing, and that you will keep paying for every second until the day you stop breathing entirely. The controlled burning happening in your cells right now doesn't pause when you're not thinking about it. It didn't pause while you were asleep last night. It won't pause while you're distracted tomorrow. It is running constantly, silently, in the background of every moment of your entire life, converting the same gas that once nearly ended everything into the only thing currently keeping you conscious enough to think about it. There's something genuinely strange about sitting inside that fact. You are, at every instant, a live truce between your own cells and a molecule that spent its early history as close to an existential weapon as this planet has ever produced. Not a metaphorical truce, an actual, ongoing, biochemical one, playing out in real time inside your chest, whether you pay attention to it or not. Most people go their entire lives without ever once being told that the air they depend on used to be the thing they'd have needed protecting from. You now know. And you can't ever fully go back to not knowing it. Not the next time you're out of breath. Not the next time you notice yourself inhaling without thinking. Not the next time someone tells you to just breathe. There's a question sitting underneath all of this that I haven't answered yet. Because honestly, nobody has answered it fully. I mentioned earlier that oxygen-producing photosynthesis seems to have been invented long before oxygen actually started piling up in the atmosphere, that there was a lag, a gap of unknown length where the gas was being produced and just as efficiently being erased. I told you about one piece of that puzzle, the nickel famine slowly starving the methanogens that had been mopping the oxygen up. But exactly how long that lag lasted precisely when the water-splitting trick was first invented relative to the moment the Great Oxidation event finally broke through. That's still genuinely unsettled ground in this field. For a while, researchers thought they had biological evidence pinning the origin of that photosynthesis down to hundreds of millions of years before the Great Oxidation event itself, a specific chemical fingerprint, a kind of molecular fossil found in ancient rock and used to argue that oxygen-producing life was already ancient by the time the atmosphere actually changed. That evidence has since been challenged so thoroughly that most of the researchers who work in this area no longer treat it as reliable. It's a useful reminder, buried in the middle of this story, of how this science actually works. It isn't a settled inheritance handed down complete. It's an active argument still being fought over, with old evidence getting quietly retired when it doesn't hold up, and nobody quite agreeing yet on exactly how long life sat on this invention before the planet caught up with it. What that means is this. Somewhere in Earth's history, there was a stretch of time, we don't know if it was millions of years or tens of millions of years, where the fuse had already been lit, and nothing on the planet, including whatever was doing the lighting, had any way of knowing what was coming. The mechanism for planetary poisoning already existed, quietly running in the background, invisible, unremarkable, while the methanogens kept eating the byproduct as fast as it appeared, and every living thing on Earth carried on as though the world it knew was permanent. It wasn't a bomb with a visible countdown. It was a fuse nobody could see, burning through rock and ocean chemistry for who knows how long, before the day the arithmetic simply ran out. I find that almost harder to sit with than the poisoning itself. Not that the change happened, that the cause of it had already been sitting there, already active, for some unknown stretch of time before anything alive had the slightest way of detecting it coming. And even once that threshold broke, even once the seam in the rock closed and there was no going back to an oxygen-free world, the story didn't resolve itself quickly. This wasn't a single afternoon of crisis followed by recovery. The window where that sulfur fingerprint vanishes for good closes by around 2.32 billion years ago, but the instability it set off kept rippling through the oceans and atmosphere for a very long time afterward. The productivity collapse I mentioned earlier, the one Hodgskiss and his colleagues found evidence for, sits at around 2 billion years ago, which means there's something like 300 million years standing between the moment the atmosphere first tipped over into a new chemical state and the moment that same transition was still violent enough to knock global biological productivity down by more than 80%. 300 million years. Try to hold that number the way you'd hold a much smaller one, because our instincts are built for hours and years, not for this. If you tried to represent the entire span of human civilization, every pyramid ever built, every war ever fought, every book ever written, on the same timeline as that one thermal instability the oxygenated Earth was still working through, human civilization wouldn't register as a visible mark. It would be smaller than the width of the line you'd use to draw the timeline itself. This wasn't a single crisis. It was a crisis with an aftershock lasting longer than the entire history of complex animal life that would eventually follow it. And somewhere inside those 300 million years of ongoing instability, the balance of the whole planet's chemistry was still being renegotiated over and over in ways the fossil and isotope record only lets us see in the broadest outline. Oxygen levels weren't simply flipped on like a switch and left steady from that point forward. They rose, and by some accounts stumbled, and rose again, oceans and atmosphere still arguing with each other over exactly how much of this new gas the planet could actually hold without something else giving way. The organisms living through that entire stretch, whatever their descendants eventually became, were not living through a single bad afternoon in the history of life. They were living through a genuinely multi-generational catastrophe, one that had already outlasted the memory of every organism experiencing it many times over, with no way for any single one of them to know whether the disruption they were born into was the whole story, or just one more aftershock in a very long chain of them. That's the timescale this entire deal was actually struck on, not a moment, not even a human comprehensible stretch of history. A process so long that measuring it in years barely means anything anymore, ending, as far as the evidence currently shows us, With the oceans finally settling into something like the oxygen-rich world you'd recognize today, 300 million years after the sky first irreversibly changed. And here's the strangest part of the aftermath, the part that never quite gets the attention it deserves. Once the atmosphere finally settled, once oxygen was, by any reasonable measure, freely available in the air and the oceans, complex life did not rush in to take advantage of it. Nothing sprinted through the open door. Instead, the fossil record goes almost eerily quiet for an enormous stretch of time afterward, a period so uneventful, so lacking in the kind of dramatic biological innovation you'd expect once the fuel supply had improved 15-fold, that some researchers half-jokingly call it the boring billion. Roughly a billion years of relatively simple, mostly single-celled life, sitting on top of an energy resource that should, in principle, have been able to build something far more elaborate and largely declining to do so. Think about how strange that actually is. You've just been told about a 15 times energy dividend, a furnace so much more powerful than fermentation that it should have been an open invitation to build bigger, more complex, more energetically expensive forms of life almost immediately. And instead, for roughly a billion years, the most complicated things swimming around in Earth's oceans were still, for the most part, single cells, quietly going about their business as though nobody had told them the rules had changed. Nobody has a fully settled answer for why. Access to a fuel isn't the same thing as having the machinery built to spend it. It's a little like being handed the keys to a much faster car in a world that hasn't built roads yet. The energy was there. The architecture needed to turn that energy into something like an animal, a nervous system, a body with organs that had to be invented separately, slowly, unglamorously, cell by cell. And there was no guarantee it would ever happen at all. For most of that billion years, it looks very much like it might not have. Whatever finally broke that stall, and there are competing ideas about it, none of them fully agreed upon, it eventually did break. And once it did, everything sped up in a way that looks, from a distance, almost like a delayed explosion. Complex multicellular life, then animals, then, eventually, nervous systems, movement, predators, and prey. All of it running, ultimately, on the same 15 times dividend that had been sitting there, mostly unused for that entire quiet billion years beforehand. The debt had been available the whole time. Life just hadn't yet figured out how to spend it. Picture, for a moment, what available oxygen actually meant during that billion-year stall, because it wasn't the same abundance you're breathing right now. For most of that stretch, the best evidence suggests atmospheric oxygen sat at levels far below what surrounds you today. Not a roaring fire, more like a bed of embers, present, real, usable, but nowhere near hot enough to fuel the kind of large, active, oxygen-hungry bodies that would come later. A single-celled organism doesn't need much of that furnace to get by. A nervous system does. A muscle that needs to contract in a fraction of a second over and over for an entire lifetime needs considerably more than embers. It needs something closer to what you have access to with every single breath you take. So the story of that quiet billion years isn't really a story about life declining to use an abundant fuel supply. It's closer to a story about a fuel supply that hadn't yet grown large enough to support anything bigger. And then, somewhere toward the end of that stretch, something changed again. A second rise. Oxygen levels appear to climb a further step later in Earth's history on top of whatever baseline the Great Oxidation event had already established. Not as dramatic a threshold as the first crossing, and the exact timing and cause of it are less settled than the first. But the pattern in the rock points toward it happening not long before the fossil record explodes with the first clear evidence of animals. Sponges. Worms. The first bodies, with more than one kind of cell working together, needing more oxygen delivered to more places than a single cell ever had to manage. It's tempting to draw a straight line between that second rise and the sudden arrival of animal life, and some researchers do draw exactly that line. Others aren't convinced the timing lines up as neatly as it looks, or think other factors mattered just as much. A genuinely open argument, not a closed one. And I want to be honest that I'm giving you the outline of a debate here, not a verdict. But even without a verdict, the coincidence is hard to ignore. More of the fuel became available, and then, not long after by geological standards, something showed up that finally needed that much fuel to exist at all. Here's where I want to bring this all the way back down to the scale of your own chest again, because there's a number worth sitting with. The air around you right now is roughly 1/5 oxygen, about 21% give or take, depending on where exactly you are standing. That specific proportion isn't some universal constant. It's the current resting point of a planetary chemical argument that has been running, in one form or another, for 2.5 billion years, still settled, for now, at this particular figure, on this particular day, for reasons that are themselves a whole separate story of plants, rock, and ocean chemistry balancing each other out. And your body has been built, generation after generation, around the assumption that the air will keep sitting right around that number. Too little of it, and you know exactly what happens. You've felt a mild version of it if you've ever climbed to real altitude. That thinness, that slight fog behind the eyes, your body straining to run its furnace on a fuel supply that's been quietly throttled. But here's the detail that took me by surprise the first time I sat with it. Too much of it is dangerous too. Breathe pure, concentrated oxygen for long enough at high enough pressure, and it stops being a resource and turns actively toxic again. The same violent electron-hungry chemistry that shredded unprotected cells 2.5 billion years ago, still capable of doing exactly that kind of damage today, to lungs, to the nervous system, to the same tissues it otherwise keeps alive. It's part of why hospitals watch oxygen levels in a ventilator as carefully as they watch anything else in that room. More of the thing that saves you is not simply better. It is, past a certain point, the same ancient threat, wearing the same disguise it's always worn. That's the part of this whole deal that never actually went away. You didn't inherit a solved problem. You inherited a narrow window, a precise band of concentration refined over 2.5 billion years of trial and dying, where this molecule sustains you instead of destroying you. Step outside that band in either direction, thin air above a mountain pass or pure oxygen pumped in too high a concentration, and the ancient hostility comes right back, as though the truce had never been signed in the first place. You are not living downstream of a crisis that got fully resolved a couple of billion years ago. You are living inside the resolved terms of a truce that only holds within a fairly narrow set of conditions, moment to moment, breath to breath, for as long as you're alive to keep negotiating it. There's one more layer to this that I've been saving, because once I tell you, you'll understand why every cell in your body is quite so intimate with this 2-billion-year-old poison in the first place. Those furnaces I mentioned earlier, the mitochondria doing the controlled burning inside your cells right now, were not always part of you. Not in the sense that matters here. The leading explanation for where they came from is that, at some point deep in that same stretch of Earth's history, one simple cell swallowed another, not digested it, swallowed it, and somehow failed to break it down, kept it alive instead, living on inside it. And the cell that got swallowed happened to be exactly the kind of organism that had already learned the trick of burning oxygen safely, at scale, for fuel. Over an enormous stretch of time, that arrangement stopped looking like one organism trapped inside another and started looking like a single, seamless partnership. The swallowed cell gave up its independence, handed over most of its own genetic instructions to its host, kept only a small, stripped-down set for itself, and settled permanently into the role of an internal furnace, supplying the energy in exchange for shelter and a steady meal for what has now been well over 1 billion years. And it left a fingerprint that's still there in every cell in your body to this day. Your mitochondria carry their own small loop of DNA, separate from the DNA sitting in the nucleus of your cells, inherited along a completely different line, passed down to you not from both your parents, but specifically through your mother, generation after generation, all the way back. It's a strange kind of fossil, not stone, not rock, a living, functioning genetic remnant, still present and still working, of an organism that used to be entirely its own separate creature before it was folded permanently into yours. Which means the furnace at the center of this entire story, the machinery that takes the poison, controls the burn, and hands you back a 15 times energy dividend for it, was never actually invented by anything that later became you. It was invented by something else first, something that used to be free, used to be its own organism, breathing its own version of this exact same air, long before it ever ended up permanently captured inside the cells of every animal that would ever live, including every single one of yours. You are not simply the descendant of the organisms that learned to survive the oxygen catastrophe. You are also, quite literally, still carrying one of them around inside you, in every cell, right now, still doing the job it was doing before it ever became part of anyone. That maternal thread, once you notice it, opens onto something else worth sitting with. Trace it back far enough, mother to mother to mother, past your own grandmother, past every ancestor whose name has been lost to time, and it doesn't stop at some vague general point marked the past. It runs in an unbroken line all the way back toward that original moment of capture, the swallowing that never got undone. Every mother in that entire chain successfully passed a living furnace onto a daughter, who passed it to a daughter, who passed it to a daughter without a single failure for well over 1 billion years until it reached you. You are holding right now in every cell of your body the current endpoint of the single longest unbroken chain of custody in the story of life on this planet. Not a chain of memory, not a chain of culture. An actual, physical, biochemical handoff, still unbroken, still running. And it is only running because of a supply line that never stops moving. That furnace inside your cells isn't storing up a lifetime's worth of oxygen the way a tank stores fuel. It has no reserve to speak of. It needs a fresh, continuous, uninterrupted delivery, moment to moment, and the moment that delivery stops, the whole partnership starts coming apart almost immediately. You've probably heard, in some general way, that the brain is unusually sensitive to this. It's worth understanding why, because it isn't really about the brain being fragile in some vague sense. It's about the brain being the most expensive customer this ancient furnace has. Thinking, sensing, coordinating a whole body, holding a continuous experience of being a person from one second to the next, all of it draws on that energy supply constantly at a rate far higher than almost any other tissue you have, which means it's also the tissue with the least room to improvise when the supply gets cut. Interrupt the flow of oxygen to the brain, and the furnace doesn't gently power down and wait patiently for the fuel to come back. Within minutes, cells that depend on that constant energy stream begin to fail in ways that cannot be undone. Sit with what that actually means about the nature of the deal you've been living inside this whole time. It was never a permanent inheritance, banked once and secured forever. It is closer to something you have to keep re-signing, breath by breath, for as long as you're alive to keep signing it. The energy that lets you be a continuous, thinking, feeling person from one moment to the next isn't stored up anywhere inside you in any quantity that would buy you more than the barest handful of minutes of grace. It has to keep arriving, fresh, from outside you, pulled in through your lungs, handed to your blood, delivered to trillions of these small captured furnaces over and over, without pause, for every single moment you have ever been alive. There is something almost unbearably intimate about that, once you actually let it land. You are not a fixed, solid thing that happens to also breathe. You are closer to a process, a continuous, moment-to-moment event, held together by an uninterrupted stream of the very molecule that once very nearly ended everything. Stop the stream, and there isn't a version of you that persists quietly in some dormant, waiting state until it resumes. The thing that stops is you. Not metaphorically. The specific, continuous chemical event that constitutes your being conscious, being warm, being anything at all, depends entirely on that supply line never breaking, even for what would otherwise seem like a very short stretch of time. And underneath all of that, still running, is the same partnership that was struck 2.5 billion years ago in oceans that looked nothing like the ones we have now, between one kind of life gasping for survival against a poison, and another kind of life that had already learned how to burn that same poison for fuel. You are the current, temporary custodian of that arrangement, not the owner of it, not its final form. Just the point the chain has reached so far, still negotiating the same terms, breath by breath, that were first written into rock and rust and thinning ocean iron, longer ago than almost anything else you could name. And that same balance doesn't just play out inside you. It plays out across the whole surface of the planet every single day in a partnership most people never stop to notice. Every breath you take draws down a little of that fixed 21%, converting oxygen back into carbon dioxide as your own furnace runs. And across every forest, every ocean, every single blade of grass, that same ancient trick that started this entire story 2.5 billion years ago is still running in the opposite direction right now, today. Plants and algae and cyanobacteria splitting water apart in sunlight, still exhaling the same waste gas their ancestors first exhaled into an oxygen-free world, quietly topping the atmosphere back up to the exact narrow band your body depends on. You are not sealed off from that ancient event, studying it from a safe distance, the way you might study a war that ended long ago. You are one side of a trade that is still, this very second, in progress. Somewhere outside, right now, whether it's a tree outside your window or plankton drifting in an ocean you'll never see, something is still doing the job of replenishing the very air you just breathed in, running the same reaction, keeping the same truce solvent so that you can keep spending it one breath at a time. Take a breath again. The same one I asked you for at the very start. Feel it move down into your chest and know now what's actually happening in there. A poison captured, a furnace running, a billion generations of mothers handing something down without ever missing a single beat. A truce signed in rusting oceans 2.5 billion years ago, still being honored second by second inside you. Nothing about that breath looks any different from the outside. It never will. But you know now what it costs, what it's built on, and how easily it could have gone the other way. Somewhere out there, a leaf or a strand of algae just exhaled the other half of this arrangement so that you could take that breath at all. Hold on to that next time the air moves through you without your even noticing. It was never ordinary. It was only ever a truce, wearing the disguise of something ordinary, so well that almost no one ever thinks to look twice. Breathe it in anyway. It's the only deal you've got.